from the Natural History Museum of Denmark. It's on Ghosts of the Great Boreotropics, Impact of Eocene Climate Change on a Specialized Forest Beetle in the family Staphylinidae.
Hello everybody. Well, I tried to save the show because Adam Brumke is my PhD student and his Brazilian visa was delayed, so he had to cancel the last moment his trip, and I'm sure he will deliver this talk much better than myself, but I have to try to qualify that I'm at least as good as students. So this is Adam. Well, he's what can I say? He's a great student, a great colleague. A number of last years he has spent working on taxonomy, phylogeny, and biogeography of rock beetles. Because he's from Canada and moved to Europe, so mostly he was busy with the Northern Hemisphere fauna. However, he's looking globally, so he knows a bit about tropics and other regions. He just defended his PhD in Copenhagen and is moving to postdoc to the Natural History Museum in Vienna and also to the University of Vienna. And mostly now he will be mastering the 3D reconstructions of the fossils for introducing them in the phylogenetic studies. In beetles, in Staphylinid beetles, we are getting serious about fossils, and part of that will be explained, the reasons for that will be explained in my talk. Okay, so today Adam will talk about biogeography of the Northern Hemisphere, precisely more about boreotropics, this great paleobiome about its rise and fall. In the center of his talk would be these wonderful beetles. This is the genus Bolitogyrus from the tribe, huge tribe Staphylinini. The Bolitogyrus is about 1 centimeter large. It's a typically looking predatory staphylinid. In the underlying method is the divergent dating analysis, and we will be talking about the role of plant connections in shaping, or rather disconnections in shaping the current distribution patterns in the Northern Hemisphere. As we know, and for example, there was one of the symposia at this meeting about the North Temperate assumptions that many concepts in our science are strongly biased by the Northern Hemisphere for good reasons. However, this is not true for modern biogeography, which was largely shaped based on the studies from the Southern Hemisphere. Perhaps this nicely disjunct continents present some kind of giant island biogeography model, which is always kind of easier to approach, while the more continuous complicated connectivity in the Northern Hemisphere made it more complicated. There are not many review studies about biogeography of Northern Hemisphere. There are complex mountain systems and so on. But now with the new model groups, new methods, I think it's time to address these issues. A lot of evidence from fossils, different fossils, mineral indicators, isotope studies tell us that around the late Pliocene and early Eocene, there was this great, on its maximum, great paleobiome, the boreotropics, which is very important for understanding of the current biogeography, so of the Northern Hemisphere. So in the other slide, I should show that the conditions about this time, the end of Paleocene, early Eocene, were perfect for the boreotropics. From the one hand, you can see this spike of temperature, so there was very warm climate, and from the other hand, you can see a number of bridges, land bridges like Beringian Bridge, Tiberian Bridge, Tulian Bridge, and the Turgai Strait. However, there were coming up and down land connections. I mean, all these bridges, this is kind of about timing and the paleo environment is a kind of controversy in the literature, and that's why it makes this research quite interesting. So at this time I showed on the previous slide the boreotropics were on their rise, but at the Oligocene cooling of the climate and the polarization of the climate, they started to contract. And there was a lot of extinctions, and In the neotropics and in the Southeast Asia, there are now remnants of the boreotropics, which gave many lineages for the formation of the modern tropics. Africa was largely cut off from these contractions, and there were some lineages which penetrated into Africa, but the mountain ranges, the Tethys and the dry landscapes where is modern Sahara, they didn't let boreotropical elements to contract to Africa. So Boletogyrus is the perfect PhD genus, I would say, with about 30 species in the neotropics and mostly in Central America, about the same number in the Southeast Asia. And this kind of disjunction made us thinking that maybe this is a good group to test whether it could be the relic of the former boreotropics. And there are many, well, not many, but a number of studies coming from plants, from primates, alligators, ants, that kind of explore and explain the current ranges in terms of boreotropics. But of course, with all respect to these groups, especially to alligators, I must say, well, it's a pity that none of the staphylinid groups, with the group with about 70,000 described species, in many funny distribution patterns, this phenomenon was ever explored. So that's why Adam began his work on Boletogyrus. Apart from the fact that Boletogyrus is just a great-looking beetle, it's a rather specialized group living on preying on dead fungus in logs. It occurs only in the tropical and subtropical ever wet forest, and apparently it's vulnerable for paleo and possibly the modern climate change. A big body of Adam's work went into building the framework for more interpretive studies. So this is just a small fragment of the big phylogeny that he has constructed for the tribe Staphylinini, just to figure out the sister relationships of the Boletogyrus, to test its monophyly and build the evolutionary concept for his work. So Boletogyrus was placed in this phylogeny inside the northern hemisphere clade of Staphylinini. We had to describe a new subtribe for the Boletogyrus and its relatives. And yes, Boletogyrus is a monophyletic genus. So the assumption that this is a boreotropical relict was stronger after this phylogenetic work. But then Adam went further and conducted the proper dating analysis to prove his hypothesis. So it was rather straightforward analysis, but what is important to mention here is the large number of fossils, relatively large for staphylinid beetles that we used, and mostly these were newly studied fossils. So it was a big time investment to go to different collections to study fossils and to make their inventory. They will be described soon. He conducted two analyses, one with log normal priors and with the uniform priors, and the first result was encouraging that, for example, the North Hemisphere clade, where Boletogyrus belong, got the reasonable early Cretaceous age, which is consistent with the hypothesis. So it's the diversification there happened way later, after separation of Laurasia from Gondwana. So what we have in Boletogyrus, we have that the stem group of Boletogyrus is about 66 million years old, which fits the age of boreotropics, and the disjunction between the neotropical and the Southeast Asian Boletogyrus clade is about 50 million years old, which is a little bit after the disconnection of Tulian bridge. So we could kind of rule out that disconnection of the Gir bridge that happened way earlier would be the case, and the Beringian bridge, which actually existed longer, but after about this time it became rather cold, not available for subtropical and tropical organisms, also could be ruled out. So just to show again the pattern that Adam got on this map. So this is the end of the warmer Tulian bridge, and this is where we have the time, divergence time between neotropical and Asian clade. Well, of course, this is just the pattern we got. We couldn't say for sure that yes, this was what happened. There is still a lot of work to do. For example, to carefully study the origin, the area of origin of Bolitogyrus, its dispersal and then contraction of the range. There are all sorts of analysis now you can do. This is kind of future. But what is great is that already when Adam was doing his dated analysis, he discovered two new fossils. One of them is the stem group Bolitogyrus from Baltic amber, and another is also another stem group of Bolitogyrus from the Green River compression fossil in North America. So there is already growing corroboration for the hypothesis. So what should be happening now is that we try to conduct this additional work and try to survey a pile of rather confusing and conflicting literature on the boreotropics to try reconstruct the broader picture. So this is what Adam wanted to present you today, and he's acknowledging colleagues and environment where he worked. So if he would be presenting, maybe he would also acknowledge me for the supervision. So thank you very much for listening, and this is our sector behind. So thank you.
We have time for a couple of questions.
Yes, please.
Would you consider that Mississippi Eocene taxa that were closely related to the example of that boreotropical fauna?
You mean Mississippi and Chinese taxa? What kind of taxa are you talking about? Like what groups?
Freshwater fishes.
Well, it's more difficult with aquatic, but maybe something to check, because as you see, the fossil record indicates from North America the way more northern trace of these groups. So something to consider, yes.
How much in agreement are geologists with the Tuolian land ridge dated its breakup?
Yeah, so the question was how much in agreement are the geological data about the dates of this existence of the bridges and their disappearance. Well, I must say that I am not a geologist, and as you know, when you go to the primary literature and start to see the actual sources, the situation is always more complicated. But we based these dates on the most recent and comprehensive review. So, for example, there was, I forgot the authors, but just in 2014, paper published on all these bridges. I have a reference for that if you want. And there, the review said that the most recent agreement would be this data. But of course, it's not easy, and there are controversies.
Thank you very much.